Hello and welcome. Today we're doing a question from LeetCode called combination sum. It's a medium. We're going to jump right into it. Given an array of distinct integers candidates and a target integer target, return a list of all unique combinations of candidates where the chosen numbers sum to target. You may return the combinations in any order. The same number may be chosen from candidates an unlimited number of times. Two combinations are unique if the frequency of at least one of the chosen numbers is different. The test cases are generated such that the number of unique combinations that sum to target is less than 150. Example 1, we have the following candidates and our target is 7. So all combinations that sum up to 7, what are they? It's 2, 2, 3, and 7 by itself. Example 2, 2, 3, 5 are our candidates and target is 8. So all combinations that sum up to 8, what are they? We have 4 2s over here, a 2 with 2 3s, and 3, 5. In example 3, candidates is 2, target is 1. No combinations of candidates will actually sum up to target, so we return the empty output. What do we want to do? We want to find all possible combinations from a pool of candidates that sum up to our target. And we can reuse numbers as many times as we want. And we've done combinations in the past, so I highly recommend checking out that video and giving this one a shot. It's going to be very similar. But for this problem, say I have the following example. This is my candidates and this is target. This is the same as example 1 over here. Now I want to find all combinations that sum up to target. Now, if I asked you to do that, how would you do it? If you needed to write it out, how do you write out all possible combinations? Well, first you could start off with just one combination. Say we pick number 2, that is going to be a combination. So we have a combination with just number 2 over here. Now this doesn't sum up to our target, so we can't include this in our output array. And let me call that result over here. So this is still going to be empty. Now we need to try more combinations. So something we could do is just add another 2 to this current combination over here. So we would get 2, 2. Now the sum of this is 4, it's still less than target, which means we need to add more numbers to it, right? So we could just take the 2, 2 and add another 2. Now at this point, our sum is 6, it's still under target, which means we need to add more numbers to this. Now what if we added another 2? If we did that, at this point we would have 4 2s and our sum would be 8. It's bigger than target, so this is not going to work. We can't have this 2 over here. And none of the other numbers and candidates will work either because they're all greater than 2, so this is all going to go past our target. So anything with 3 2s is not going to work. Now, what if instead of having this 2 over here, we had a 3? So 2, 2, 3, this does sum up to 7, so we can use this as part of our result. This is one of the combinations that will sum up to target. Now, since this already sums up to target, there's no need to continue adding numbers to this current combination, right? We're gonna go over that sum of target. And there's also no need to replace this 3 with anything else in candidates because all these numbers are greater than the 3 we have. We've already tried 2, 2, 2. We're at 2, 2, 3. If we were to do 2, 2, 6 or 2, 2, 7, we know we'll go above target because this already equals target. So we don't need these 2s anymore. What if we switch this to be a 3? So this is another combination that I can make with 1, 2, and 1, 3. This sums up to 5. So we're still under target. We need to add more numbers. Now, what number can I add to the end of this? Can I add a 2? If I were to add a 2, so if it became 2, 3, 2, this would be the same combination as the one we had before. We have 2 2s and 1 3. And this is a repeat combination. We want unique combinations. We would need the frequencies of all these numbers to be different in order to be unique combinations. So we can't use a 2 here. So what we want to do is only use the number we are on or the one after us in candidates. We already exhausted all possibilities of 2 2s, so we don't need to include a second 2 anymore. So at this point, we have 2, 3, and we know this was 5. So now what we want to explore is having 1, 2, and 1, 3, and all the other numbers that we can add to this current combination. So what if I added another 3 over here? Now this sums up to 8, which is greater than target, so this is not going to work. We can't use 2, 3, 3. And of course, we also can't do 2, 3, 6 or 2, 3, 7. We can't go down this path. So nothing with 2, 3 is going to work. So we go back to this first index and we're done with all the combinations we can make with any number of 2s. So now we want to try all of our 3s. If we have 1, 3, we know we're less than the target. We need another one. So what number can we add onto this? Well, we know we can't go back, right? We're at 3, so the only numbers available to us now are going to be 3, 6, and 7. We don't want to go back because that's going to repeat combinations. At this point, I can add another 3, so I have 6 as my total. I can't add another 3 here because that's going to go over target. That's going to equal 9, and therefore I also can't add anything else from candidates because these are numbers all greater than 3. So this means I want to switch out 3 with another number. What if I had 3, 6? Again, that's 9. That's going to be greater than my target, so I don't want to go down that path either. And same with 3, 7, right? This means we've exhausted all combinations involving 3 that could have summed up to target. And we want to switch it now to use 6 instead. So at 6, can I add another number to candidates? The only numbers I have available here are 6 and 7. None of them are going to work. We're going to go over target. So you want to switch this instead of using a 6 to using 7. And this does equal target, so we're going to add this to our result. So our final result is going to be 2, 2, 3, and 7. Now when making all of our combinations, what did we do, right? If you notice, all we did is loop through all of our potential candidates. So that first index we are looping through, we go 2, 3, 6, 7, we cover all the candidates. Then for the next index, we want to start with the number we're on and above. So over here, this next element can be 2, or it could be 3, 6, 7, and so forth. But once we're starting at 3, we can't go back to 2. We have to start from 3 onwards. And this is sort of the main crux of this problem, to avoid duplicate combinations. But otherwise, the logic is fairly simple, right? We want to loop through all of our candidates for all the indices, and our loop range just gets smaller and smaller every single time. Once we hit target, we will append that combination to result. If we go over target, we want to go back and switch the numbers to use that next number that is available to us. So this is going to be repetitive operations, which means we can solve this using recursion. This is going to be a depth first search. We're going down an entire path, and then we're just backtrack as we finish exploring options. So let's go ahead and code this up and then do a complete walkthrough. Okay, how do we code this up? First thing I want to do is sort my candidates, right? This was in increasing order, but if that's not the case, I want to sort it so that it is. So candidates dot sort. Once that's done, I want to initialize my result array. So the result is going to be empty. And now I want my recursive function. Now I'm going to define this within combination sum over here, just because it's going to be easy to reference result and candidates. We don't need to keep passing that in. It makes for a cleaner, more concise code. So defining my recursive function, let's call that combinations over here. What are we passing in? Well, we have this current combination that we are working with. So let's pass that in. This is going to be current. And we have our target integer. Now, every time we add something to our current combination, we're going to subtract from target. So once target goes to 0, we know we found a combination that sums up to target exactly. So if target equals 0, we're going to append our current combination to result. So result.append current, and we can return from here. Now this is our base case. This is when we stop our recursive calls. Now what's our recursive case, right? If we don't go into this if condition, that means we still haven't hit that sum of target, and we want to add another number to our current combination. So for that, we're going to loop through all the numbers in candidate. So for number in range, and I'm going to be adding a starting point over here, right? So I'm going to start at a specific starting point because we don't loop through all the numbers in every single call. Suppose I exhausted all my 2s. Well, I no longer want to start with index 0. I now want to start with index 1 and onward. So I'm going to define the start over here, and I'm going to go to the end of my candidate. So length of candidates. And since this is a range, I'm going to change this to be an index I. My number is going to be what is at candidates at index I. So candidates at I is the number that I'm going to be working with. If this number is greater than my target, that means I don't want to be adding this on to my current array. We're going to be going over that sum. And no other number after that is going to work either, right? If we keep going back in this loop, we're only going to get bigger numbers. So I want to make a check. If candidates of I is greater than target, I want to break out of this loop. If that is not the case, if it is less than equal to target, well, now I want to include it and make a recursive call. So I'm going to be calling combination again and passing in what we have in our current array. And to that, I am appending the number we have, so candidates of I. And I'm going to be passing in target minus candidates of I, because now our target that we need to reach is going to be less because we are using this number. Now something else I want to pass in is also this starting point, right? I'm on index I and I don't want to start from a number before me, so I'm also going to pass this in as my start point. So this is going to be start over here. Once I finish out of this for loop, all I have to do is return. And this is it. This is our entire recursive function. All we have to do is call this now. So I'm going to be calling this with the empty array. We're passing in start as index 0, and target is just going to be what we have in target right now. Once that's done, all we have to do is return our result. So let's go ahead and submit this. And it is accepted. Now, before leaving, the most important part of the video, we're going to do a complete walkthrough with some examples to see how our code is going to work line by line. This is really going to allow us to visualize it and make sure we truly understand what is happening. Just use the same example. This is my candidates array and this is target 7. Going through this line by line, the first thing I do is sort candidates. It's already in sorted order, so it's going to stay as is. Next, I define my empty resulting array and I define this function over here. So I call the function we just defined and I'm inputting the empty array, 0, and my target, which is 7. So passing this in over here, we have current being the empty array, start is 0, and target is 7. Now, first thing we do is check what target is. It's not 0, so we don't go in this if condition. Now we're looping through. We're looping through from start to length of candidate. So we start at index 0. So I right now is 0. We go in this for loop, candidates of I. So what is at index 0? That's 2. This is not greater than 7, so we don't break. And we make a call. So we're going to call this again with our current array, which is empty, plus candidates at I. So this is 2 over here. We're appending to our current empty array, just 2. So this is going to become just an array of 2. We have I, which is our index of 0. So we're passing that in, and target minus candidates of I. So our new target is 5. We go back in this function, target is not 0. We don't return. And we loop through from starting index 0. So I starts off at 0. We don't break here. Candidates of I is 2. It's not greater than 5. And we call this again. So what do we call this with? Now our current array is the array of 2. So we're going to append to this candidates at I. Candidates of I is 0, so we're adding another 2 to the end of this. So now this is just going to be an array of 2 2s. I is still 0, and target minus candidates of I, that is going to be 3. We're back in this function, target isn't 0. We loop through, again starting at I being 0. Here, candidates of I, so 2 is not greater than 3, so we don't break, and we call this one more time. So we have 2 2 being our current array. And we're passing in candidates of I, which means we have 3 2s at this point. I is still 0. And target minus another 2, that is going to be 1. So this is our new call. We call this again, current array is an array with 3 2s, start is 0, and target is 1. Target isn't 0, so we don't return. We're back in this for loop. So I equals 0, and we make a check. Candidates of I, so what's candidates at 0? That's 2. 2 is greater than target, so we're going to break out of this. There's no point in adding more numbers and making more calls. So we're out of this for loop, and we just return to our caller. We go back up, and we're back in this function over here where we had 2 2s, and we were in this for loop with index being 0. Now we're back in this for loop, so now index is going to be 1. Now that index is 1, we're going to be calling this again with candidates of 1. So our current array is still 2 2, and what's at candidates of I? That's now 3. So adding this together, we have a 2 2 3 array. I is 1, and target minus candidates. Our current target was 3. The candidate that we're using is also 3, so this is going to be 0. So we call this function again, and this time target is 0. This is the target that we're passing in. So we're going to append our current array that we've passed in to result. So this is appended to result, and we return. So we go back to our caller. We just finished this call over here, right? With I being 1. So we're back in this for loop, and now I is going to be 2. Now with I being 2, we make a check candidates at I. That is going to be 6. 6 is greater than this target of 3 that we have. So we break. We're out of this for loop, and we return. So we go back to our caller where we had just that 1 2. Now here, we finished that call with I being 0. So now we go back in this for loop for this function and move I up to index 1. So now we check candidates of I is 3. 3 is not greater than this target we had in this call, which was 5. So we call this again. In our current array, we had just this 2, and I is 1. So we're adding candidates of I to this array. So we're appending 3 to the end of this. I is 1. And target minus candidates of I, that is going to be 2. So we're recursing, right? We're just going back in this function. We're just going to keep calling it over and over again. And we check target is not 0. We go back in this for loop. Here, we are ranging from a start to the end of our candidates. But our start is 1, so we start off I at 1. This is to make sure we don't check any previous element, right? We don't want duplicate combinations. So now that we're in this for loop, I is 1, we check candidates of I. That's going to be 3. Is 3 greater than target? It is, so we break. There's no need to go down this route. We return to our caller again, so we just finish I being 1 for this function. So now I is going to be 2, and we're back in this for loop. So at 2, this index over here, we have number 6 is greater than target, so we break and we exit this for loop, and we return to our original caller. Now this was our original call, right? We just finished I being 0. So now we're going to go back into this for loop and call this with I being 1. So calling this with I being 1, right? We make this function call. Our current array is empty. We're adding to that candidates of I. So we're adding to that 3, which means we just get the array of 3. I is 1. And what's target minus candidates of I? So 7 minus 3 is going to be 4. So now we make this call over here. We see that target isn't 0, and now we're going to loop through from start onward. So start is 1 over here. I'm also going to write this out just to define this further. So now we have I being 1. We check candidates at I. That is 3. Is 3 greater than target? It is not. So we make this call over here. Now this call over here, we're just adding 3 to our current array. So we get 3, 3. I is going to be 1. And target minus candidates, 4 minus 3 is 1. So this is the new call that we're making. In this function again, target isn't 0. We loop through again, I is 1. And we make a check. Candidates of I here is greater than target. 3 is greater than 1. So we break, we exit this for loop, and we return. So over here, we just finished this call. We go back in this for loop. I is now going to be 2. We loop through and we check candidates of I. This is 6. 6 is greater than the target we have. So we finish exhausting all options with 3 and we return to its caller again. Now we're back in this caller over here and we finished going through I being 1. So we're back in our original for loop with I being 2. So we make a check over here. Candidates of I, that is 6. It's not greater than the target we have, so we're going to make this call. This means we're going to be passing in an array of just 6. Our new start point, which is I, which is going to be 2. And our target is going to be 7 minus 6, which is 1. So now this is a new path that we're exploring with 6s. We're trying all combinations, right? We try out a path as far as it can go back up and try out another path. So this is another path that we're trying out. We make this call over here. We check target isn't equal to 0, so we don't return. And now we loop through from I being 2, so I is going to be 2. And we check candidates of I, which is 6. It's greater than the target we have, so we break, exit this for loop, and return. There's nothing with 6 that's going to work. Going back into our original for loop, we now move index I to be 3. We're back in here, we check. Candidates of I, which is 7, is not greater than target, so we don't break, and we call this function again. So passing it in with the following, we see that target is 0, so we're going to take this current combination that we have and append it to result. So now result holds 2, 2, 3, and 7. We return from here, and we go back into this function over here. So we go back in this for loop, and there's no other element to iterate over. There's no other index. We hit the last one. So we're done with this for loop, and we return. So we return this final call over here. We just finished calling this. And now all we do is return result, which correctly holds all combinations that sum up to target. Now, time complexity for this solution is going to be 2 to the t if t is target. It is an exponential approach because we're exploring all possible combinations. Now, a way to do this a little bit better time-wise, but we would be using more space, would be to use dynamic programming. So in order to do a dynamic programming approach, say we had the following input, candidates are 2 and 3 and target is 5. What we want to do is define an array of length target plus 1. So we go from 0, 1, 2, 3, 4, all the way up until target. Now we're going to initialize every single index to have the empty array. This is going to store all the combinations we need to sum up to the index that we have. So at 0, the only thing that will sum up to it was the empty combination. So that's just going to be the empty list over here. Next, what we want to do is loop through all of our candidates. So say I start off with candidate 2. I'm going to start off at the value of my candidate and see if I can make that combination. So I'm going to go 2 before me because I am candidate 2. I start off at index 2 as well. And I see that I can make this over here, right? It's the empty array. So I need to add to that my own number. So I'm going to take all the ways to make this combination, not just a way of 0, an empty array, and I'm going to append to that an array with just my number. So I'm going to have an array of 2 to be able to get to 2. Now I go on to my next index. I'm at index 3. I want to see all the ways to make a combination of 1. There's no way to make this. This is an empty list. So I can't make 3 with candidate 2. Now I'm go to 4. All the ways that I can make 2, I'm going to just take that and append another 2 to the end of this. So 2, 2 will give us 4. I go to 5. There's no way to get to 3 though, so there wouldn't be any way to get to 5 with candidate 2. Now I exhausted everything with 2. I want to move on to my next candidate, which is 3. I do the same thing again, right? I start over here. I see there is a way to make 0. So I'm going to take all of those possibilities and just append 3 to that. Now I go to 4. 4 minus 3 is 1. There's no way to make 1. So with 3, I can't make a 4. I move on to my next index. That's 5. Now with the 3, can I make a 5? I go 3 down and I see there is a possibility to make 2. What are all the combinations that give me 2? That's going to be stored in here. So to each of those, I'm just going to append a 3. Now we only have one option that's just a combination of 2. So to that, I'm just going to append a 3. If we had another way, so if we had the following, I would take this as well and just add another 3 to the end of this. And in the end, whatever's stored in this last index will give me all the combinations that sum up to my target. Now, time complexity wise, it is a little better. We have a more hard cap because it's not exponential. This is going to be an O of target, let's call that T, times N if N is the number of candidates that we have, times K if that's the average length of combinations that we have, because we will be copy pasting them over. So it has a harder bound on time, but we are using more space. We're storing everything in an array. So there is a sort of trade-off with that. Also go ahead and code this up just to know how this works as well. So what do I want to do? I want to initialize my resulting array. It's going to hold a list of empty lists for everything in the range of target plus 1. So for in range target plus 1. Now that we've defined it to be empty lists, I want to initialize what I have at 0 to hold a list of an empty list. So result at index 0 is going to equal the following. This is going to store all the combinations that it takes to get to the sum of 0, and that's just going to be one combination of the empty list. Now I'm going to loop through all my candidates. So for candidate in candidates, I'm going to be looping through for all the indices from candidate onwards. So if I have candidate 3, I'm going to check from 3 onwards, right? There's no point in checking before. I wouldn't be able to make up that number because we need negative numbers to sum up to something that is a number lower than us, right? So for I in range candidate to target plus 1. So we're going to be looping through all of these. Now I want to check everything candidate before me. So if I'm at 3, I want to check everything at 0. If I'm at 4, I want to check everything at 1 and see all the possible combinations to make that number. So we're going to loop through all combinations that are stored in those indices. So for combinations in result I minus candidate. Now with all of these combinations, I'm going to append my own candidate number to that and add that to the resulting array. So result of I dot append the combination that I have in my current indices candidates before me plus my own candidate. And once I go through all of this, all I have to do is return what's in this last index. So I'm going to return result of target. So let's go ahead and submit this. And it is accepted. Now to quickly visualize this, say I want to run this again with the previous example I had, right, with 2, 3, 6, 7. I'm just going to add a print statement over here so we can visualize how this works as well. So running this code, right, we see we're looping through from 2, 3, 6, 7. I first start off at 2. I fill in my 2 over here. I see that index 4 is going to be 2, 2. Index 6 is going to be 2, 2, 2. And then moving on to 3, we can make a 3 here. We can make 2, 3 with 5. And we have all of our 3s over here. And as we go down, we have all the combinations like so. That will give us our target. So we just went ahead and solved combination sum. We did it 2 ways, both through dynamic programming and our recursive backtracking approach. There are trade-offs with both, so depends on what your requirements are. If you have any questions with this, either solution or the problem in general, let me know down below. I will answer all of them. If this video was helpful, like, comment, and subscribe. It really supports the channel. And as always, I will see you in the next one.